Okay, higher level. We're now going to look at partial fraction decomposition, which is going to be a strategy you'll need to know in order to solve and graph functions, rational functions other than linear divided by linear. For now, in doing this, we're just looking at where the denominator is a quadratic and the numerator is a constant or a linear. So a partial fraction is where you take something, for example, this function as a linear divided by a quadratic, and you break it up into pieces that are also functions. So parts that are different functions where you have a constant divided by a linear with another term that's a constant divided by a linear. This is just a coincidence that they're both minus. They could be plus or minus. It doesn't really matter if you have a linear in the numerator or a constant in the numerator. They will work the same. Okay, so now we're going to look at what strategies you need to get from here to here. Of course, you should be acquainted with how to get from here to here. That's not a challenge, really. You just make sure that they have the same denominator and then add the numerators. Okay, so one thing we will need to know is how to factor these quadratics. I know we've spoken about it a little bit, but the order's been a little bit wonky this year. So in order to put these partial fractions as denominators in linear terms, we're going to factor this denominator. So when the coefficient of x squared is 1, it's quite simple. We can just say, okay, well, what two things multiply to -2 and add to -1? Okay, that's a -1x. And in that case, we know that -2 times +1 is -2, and -2 plus 1 is -x. So I could write the denominator as x minus 2, x plus 1. And these are going to be what my two denominators are going to be, x minus 2 and x plus 1. I don't yet know, though, what constants these are going to be. That's the big question that we're going to try to find out. Now, what we can do is remember the fact that if I wanted to go back and say, well, I actually want to write this here, I would multiply this fraction by x plus 1 over x plus 1, which is 1. So x plus 1. And then I still have my original denominator. And in the same vein, I can do, okay, well, this, in order to get this over the x minus 2, x plus 1 denominator, I'd have to multiply both by x minus 2. Now, because all of these things are equal, what I could say is that this equals this. Okay, that's how we add fractions. So if I have 5x minus 4, I know it can be written as a x plus 1 plus b x minus 2. And the way we're going to find these values of a and b is quite simply just trying a few really nice values and say, okay, I'm going to substitute. What if x is -1? Well, if x is -1, then 5 times -1 minus 4 plus 1, and b -1, just substituting it in. And then we get -5 minus 4 is -9. This is going to be 0, so it actually cancels that out. And it makes this quite simple. And then we get plus b times -3. And that means that b is equal to 3. So we have that. Oh, and then we're going to do the exact same thing with the other one. We're going to say, okay, well, what about if it's 2? We can do the same thing. If I put in 2, I'm going to go a little bit faster here. Putting 2 into this side, I get 6. A 2 plus 1 plus b 2 minus 2. That's gone. So 3a equals 6, or a equals 2. And then you have your partial fractions. So the partial fractions in this case are going to be a is 2 over x minus 2, and b is 3 over x plus 1. And there's our partial fractions. We'll look and see how this affects the graph of this rational function in a few days. Here's a slightly trickier one, especially looking at and reviewing just how to factor these quadratic functions. If you do have a coefficient of x squared, you're going to first need to multiply these. And 3 times 8 is 24. So we're looking for two numbers instead that multiply to 24 and add to 14. And the pair that multiplies to 24 and adds to 14 is 12 and 2. So we need 12x and 2x. And there are a few different methods of doing this factoring. I'm just going to use this box method. I have 3x squared and 8. Okay, if you don't remember how to factor and want to specifically look at that, I realize that's a bit messy. Let me try to make that a little bit nicer here. That's not a whole lot nicer. And 8, and I know I'm going to combine 12x and 2x. Key to this is that there's no greatest common factor of these terms that I can pull out. And then I'm just going to look at each row and each column and say what's the greatest common factor. So I can pull a 4 out of both of those, just an x out of both of those, 3x out of this column, and a 2 out of that. And you pick the sign of the closest box. Positive, 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 positive in this case. Nice and easy. So this negative 8x minus 2 over 3x squared plus 14x plus 8 can be written with a denominator of 3x plus 2 times x plus 4. Okay, and we want to find a way to write this as some constant over 3x plus 2 plus some other constant over x plus 4. Okay, oh, that has disappeared here. Now remember that this we could multiply out, okay, and say, well, if I were to write this again, I could say, well, a times x plus 4 is going to be over the same denominator as the original one. We're just multiplying by a special 1. Okay. And then it's going to go in the exact same way as before. Okay, if you had a constant, it would be even easier than having this linear term because you wouldn't even need to substitute it, but it does work exactly the same. I now want to say negative 8x minus 2 equals a x plus 4 plus b 3x plus 2. I'm going to use this value to make it 0 first, so it doesn't matter which one you do first, but I'll just do this one here. So when x equals negative 4, negative 32 minus 2 is going to be, excuse me, that's positive 32 minus 2 is going to be positive 30. This will turn this whole a term into 0. It'll be gone. And if I put in negative 4 here, I'll get b times negative 12 plus 2, which is equal to negative 10. So negative 10b. So that implies that b equals negative 3. And then the other one we want to do, again, where would this equal 0? Well, that will equal 0, subtract 2, and divide by 3, when x equals negative 2/3. Fractions are no fun, but they come up, and they're not hugely problematic. If you put negative 2/3 in here, negative 8 times negative 2/3 is positive 16/3, and then take away 2, which is 6/3, so 16/3 minus 6/3 is 10/3. This a term is still going to be there. I'll take that a little bit more slowly, don't have to. But the b term will be 0 now. So what this will be is going to also be 10/3 because this is 12/3 minus 2/3 is equal to 10/3. So 10/3 equals a times 10/3. So a is equal to 1. Okay. A is equal to 1, and now we have the constants in the numerators due to our partial fraction decomposition, where we have that this fraction is equal to, I'll write it up here actually so it's a little bit easier to see. That's equal to a is 1, 3x plus 2, minus, because this was negative, 3 over x plus 4.